Welcome back to the fourth part of the QFTest video tutorial about testing web UIs with QFTest. This video covers section 13, components, which can also be found in the written tutorial. As already mentioned in the first part of this video tutorial, I would like to point out that this video tutorial deals with testing web UIs. We use testing web UIs in place of all supported UI technologies like Java and Windows because the concepts and usage of QFTest are more or less the same. You can find explicit hints about the marginal differences in the written form of the tutorial. So today we discuss the basics of the recognition algorithm of QFTest. We will learn how QFTest recognizes graphical objects like buttons, text fields, checkboxes or tables, as well as dealing with content of tables or trees. Such graphical objects are called components in QFTest. Besides components which you can directly interact with, like buttons and so forth, QFTest also knows so-called subitems. Subitems represent data records of tables, lists, or trees. The first part shows how to address such data records. Afterwards, we will take a look at the Windows and Components section. In this section, we will discuss the basics of the component recognition once again. Let's start with addressing data records of tables, lists, or trees, so-called subitems. Therefore, I opened the demo test suite First Web Tests QFT from the tutorial folder of the QFTest installation. You can also reuse the test suite from the previous section. First, we should start the web application again to be able to interact with the application and its content. So I select the setup node and start it. So that we can gradually approach the concept of component recognition, I would like to record a click on one of the vehicles shown in the table now. So I start the recording and I click on the first model, like Wallow in my case. Once I stop the recording, the sequence contains a mouse click with the value vehicle table at model %0. I see the same value in the attribute QFTest component ID of the mouse event. But what does this value actually stand for? This value consists of three parts. The first part, vehicle table, at the beginning stands for the whole table. So vehicle table describes the QFTest ID of the table component, including all columns and rows of that table. The second part, which is at model, describes the actual table column which was selected during the click. In our case, I clicked at a value inside the column model, which we see here in the heading of the column, and so QFTest records the click inside the column model. The at character here tells QFTest that the table column should be recognized by its heading text, model in my case. There are also other ways to address a table column, for instance by its index and so on, but that's something which we will take a look at later. The third part of this QFTest ID is the part to address the row itself. %0 stands to address the first row. So ampersand tells QFTest to address any subitem by its position or by its index, as it's called by QFTest. The index in QFTest is 0-based, so the first entry is always addressed by 0, the second is always addressed by 1, the third is addressed by 2. And the actual index is then the number what we see here. In the recent recording, we have seen how it's possible to address table records either by text using the at character or by ampersand using a numeric index. Now let's explore how to work with those operators and what else we can do within the QFTest component ID. As first exercise, I would like to select the third entry of the column price. So in my case, I would like to select the value of $17,000 here. The first variant To deal with that might be a simple recording. So I start the recording and I click the $17,000 and stop the recording. The recorded sequence contains a mouse click, and in the QFTest component ID we see vehicle table at price $2, which exactly stands for the third entry in the column price. In order to show the different options now which we have, let me copy the mouse click and paste it. Instead of using at price to address the column by its text, I could also change this to something like $1, which means address the second column, and the price column is actually the second column. By the way, whenever you select a mouse click in the QFTest test suite, the corresponding target component or sub-item is getting highlighted in the web application. So you see, once I click at the mouse click, the value of $17,000 is being highlighted in the application. So that's a very comfortable way to check whether your modifications are still hitting and matching the desired target. So after addressing the table column, let's play around with the table row. So I'm again copying the mouse click, and instead of using $2, I could also change this to use the at character to something like 17,000 $, and if I select it, you see the value is again highlighted in the application. So you see, you can also use the at character to address the text of a table row, but it must be the full text, so the $ character and the $17,000 including its formatting. Admittedly, selecting the price by its text might make little sense. That's different if you want to address the model by its text. So let's say you would like to click on a specific model inside the table. Then it might be interesting to exactly address the model by its name. So if you want to click on a specific model, what can you do? We copy the mouse click, we paste it, and we change the column to something like at model. And to address the corresponding vehicle, like the last one, I5 in my case, I could type something like at I5. And if we check this via the highlighting or via replaying it, we see I5 is getting highlighted. And this way of addressing data records directly by their text makes it pretty easy to work with tables or list entries in QFTest. Besides the ampersand operator using numeric indexes or the at character using the full text of an item, there is even a third operator existing, which is the percentage. Using the percentage enables you to address sub-items by regular expressions on a full text. So this means you can use wildcards whenever you describe a model. Let me show this via addressing the family car. So I'm copying the mouse click, pasting it, and I change at I5 to percentage dot asterisk family. And if I select that entry now, the family entry is being highlighted in the table. The percentage operator highlights the first entry, which is actually matching the specified pattern. You can find more about regular expressions in the QFTest manual or on other videos on this channel. Addressing table content in QFTest works by using two dimensions. You use the column and the row. Lists or tab folders require only one dimension. So let me record a click on the Specials tab and stop the recording. And our recording looks like that we have the tabbed pane, which is actually the entire tab folder, and then we have the at operator here again, which tells QFTest to address the tab by its text, which is Specials. We can also change this again via copy-paste to select the first tab, for instance, which is then highlighting the vehicles tab. So we can also use the same operators at, ampersand, or percentage to address items of lists or tabs. This works for such tab folders as well as for selection boxes like this. And there is one more kind of lists in applications available. There are trees, so you can call them structured lists. In the demo application, you find a tree in the options Specials menu. Then you select the special and press Details. And there you can find a tree. So let me record a click at the description node and stop the recording. What gets recorded? We see Details tree, then we see the add character /information /description. The add character again means address the content of the tree by its text. Which content? The first level of the tree /information stands for the topmost node, which we find here, which is information. And then /description stands for the next level of the tree. So description is a child of information, and this has been separated by the slash. So whenever you access trees, you can address the tree nodes by its text using the add character, but you need to take care to use the slash operators as well to identify the respective hierarchy levels of the tree. And that's the same if you want to address the tree node by a numeric index. So if we copy and paste the mouse click again, we can change this to address description by ampersand /0/1, for instance, which is also highlighting the description node. And this means to QFTest address the first node /0, and from the first node take the second child, which is description. For completeness sake, let's just check what's happening if we address /0/0. Oh, yeah, we see accessories is being highlighted. That's fine. In summary of this section, we can say QFTest is very flexible in addressing data records of tables, lists, and trees. Such data records are called subitems in QFTest. As we can successfully address subitems now, we should examine the components themselves. Therefore, let's open the sequence or the test step check final price of the first test case. This test step contains a check text to calculated price. If you select calculated price, you see the final price field in the UI is being highlighted. If we take a closer look at the QFTest component ID there, we see just the value calculated price, which actually doesn't give us any hint about which text field is being taken into account for this check, as we don't see the text calculated price anywhere in the application. If we click the check text, we see the final price field being highlighted, so it seems to be the right one. But actually, where is the connection between the final price field and the value calculated price? We can't use any adds and ampersands here in the QFTest component ID. And the solution of that question is that QFTest recorded one more node having that QFTest component ID, calculated price, as unique ID. And we can find that node via opening the context menu on the check text node, and then we choose locate component. Now QFTest jumps to a node located inside the Windows and Components section, and we see it's a text field node with the QFTest ID calculated price. And calculated price is the value what we see in a check text. If we select that component node, also the final price field gets highlighted in the web application. Please keep in mind that whenever you record actions or checks in QFTest during the recording, QFTest also records a component node inside the Windows and Components area. This component node contains the information how the graphical object will be identified by QFTest. In case of the check final price sequence, the check text relies on the component calculated price. So what does this component node actually contain? What is the component node all about? As you can see, those components are recorded in some kind of hierarchy. The text field is part of a panel, the panel is part of a body, the body is part of an HTML object, the HTML is part of a web page. QFTest records a filtered structure of the web page depending on the web application itself. This structure can be influenced by the web application's developers or by the custom web resolver, which we have seen in the previous section. Depending on the quality of the custom web resolver or the application, you can end up in a very deep hierarchy or in a flat hierarchy like I have. In case you get a hierarchy with 20 or 30 levels, you should consider to optimize the component recognition by utilizing a custom web resolver. So what are the details of the component node now? The first detail, QFTest ID, represents a unique name to this component from a QFTest perspective. So you could call this also a business name of that component. This ID can be found in any recorded node to identify the technical attributes like mouse clicks or like the check text nodes. You are allowed to change it if you want to. As the QFTest ID is just the key to find that component node, let's now focus on the real technical attributes, which are all the remaining ones. The first one is the class attribute, which stands for the type of the component, like text field, buttons, table, and so forth. This information has to match in any case in order to identify that component. So QFTest is looking for text fields whenever you access calculated price. The next attribute, name, is a technical name of the component. This technical name is either an ID or name set by the development team or by the utilized UI framework. The standard algorithm of QFTest assumes that the combination of class and name is sufficient to identify the component, and all the other attributes are ignored. So in our case, whenever you access calculated price, QFTest looks for a text field having the technical name, the technical ID, calculated price. And that's sufficient to identify the final price field. If no name is assigned to the component, which is happening quite often, and I'm pretty sure it's also happening in your application as well, QFTest takes all the other attributes which are recorded into account. Those attributes will be combined in a probability calculation. Okay, what are the ingredients of that calculation? The first one is the feature. The feature stands for the main label of a component or of very specific HTML attributes. In our case, it's also the value of the ID attribute. But you could also find the text of a button there if you deal with buttons. The extra features contain further HTML attributes or QFTest attributes which have been calculated. You can find HTML attributes like class, ID, or even the information about the HTML tag. Or QFS calculated attributes like the QFS label, which stands for a label describing the text fields. And in our case, final price is the label describing the text field. You can also find information like QFS class, QFS generic class, or QFS system class, which contains information about the way how QFTest resolves classes. But that's a very, very, very technical topic, which we can just skip for now. QFTest only takes extra features into account, which have the state should match or must match. If the state is set to ignore, like in most cases here, those attributes are just recorded for your reference, but they are not used. Then you find the block of structure information. And there you see the class index and class count information, which actually means that here we have the text field of 6. The index is again 0 based, that's why 5 stands for 6. And the last information is about the geometry of that component. So here you see the size information, width and height, as well as the location inside its parent x and y. All those attributes will be taken into account for the probability calculation for every action which accesses the component by that particular QFTest ID, but only if no name has been set. If you record an action on an already recorded component, QFTest will reuse that component node. So you won't get one component for every click. QFTest will reuse the components if QFTest is able to recognize the component again. It's important to know that QFTest always changes 2 locations inside a test suite whenever you recorded actions or checks. The actual mouse click and check nodes and so on, they will be stored to the extras. And QFTest is also checking the Windows and Components node. If there is already a component which could be recognized with that information you have clicked on, the component will be reused. And if the component is not there, QFTest will add one more component to that section. By the way, sub-items from the previous section can also be recorded as such a dedicated sub-item node inside the Windows and Components area. That might be an interesting use case if you deal with very static tables or lists. On this video channel, you can find further videos about details of the component recognition algorithm, and you can take a look in the QFTest manual, which also contains a very detailed chapter about it. And there are even videos on this channel dealing with best practices of solving component recognition problems. Future QFTest releases will extend that concept by using smart IDs. This concept allows you to work without recorded components, which is pretty handy in particular use cases. Approaching the end of this video, let's summarize what we talked about. We have seen that it's very simple to address sub-items, which stand for data records in tables, lists, and trees. We can use the ampersand, the @ or the percentage operator to use numeric indexes, a full text, or even a regular expression to identify the desired sub-item. And we took a look at the basics of the component recognition inside the Windows and Components section. And there it was important to know that QFTest really uses technical information directly from the web application in order to recognize components. Generally speaking, there exist 2 ways recognizing components in QFTest. The first way is recognize a component by its class and its name. If a name is set or if no name is set, recognize the component by its class and the other features which have been calculated within a probability calculation. A stable component recognition is the key factor determining the success of any UI testing project. QFTest is very well positioned in this area, and it provides the custom web resolver to improve that more and more. The next chapter is about analyzing a test suite step by step using the debugging concept of QFTest. Until then, enjoy exploring the components in your application and figure out how the components could be recognized in your application.